Hi, and welcome to this section of the Matrix Algebra Tutor. And the title of this section is called Matrix Inverses, or another way to say that is how to find the inverse of a matrix. Okay, I don't know about you, but when I first learned this, the word inverse really scared me, really worried me, and made me feel like this was going to be a really hard thing to do. And I won't lie to you, it can be a little bit tedious, but it's not hard, especially just to understand the concept of what a matrix inverse is. It's not hard. Well, let me ask you a question. What do you think the word inverse means, just in everyday language? The inverse of something is something else. I mean, roughly speaking, everyone's going to have their own little definition, but inverse is kind of like the opposite of something. It's sort of like the other side of something, the inverse. Whatever else you haven't done that's left over, that's kind of like the inverse, okay? And we'll see that when we find the inverse of a matrix, it's a rough translation, but it roughly means the opposite matrix, sort of, and you'll see why that's the case. But the good news is that you actually already know what the inverse of something is mathematically already. You probably just either forgot or were never really told explicitly, but you already know what this is. For instance, a long time ago, you probably may not remember this, but you actually learned what's called the multiplicative inverse, and that actually sounds scary even by itself. But let me show you how a big word like multiplicative inverse is really actually simple. And so when we get to the matrix inverses, you'll see that that's not so hard either. Okay, so recall back from I don't even know, 7th or 8th grade. I'm not even sure where, but the multiplicative inverse. And this is just done here to give you a little background motivation, so when we get to the matrix inverses, it won't seem so hard. The multiplicative inverse of, and you know me, I like to teach by example, so I'm not going to give you a giant definition. The multiplicative inverse of, let's say, the number 5. There's a number. What's the multiplicative inverse of that? Is 1/5. Okay? And the reason is because, and this is really the definition of what the inverse means, because 5 times 1/5 is equal to 1. Okay? That's something you should know. 5 times 1/5 is equal to 1. Okay? That is the definition of a multiplicative inverse. It's basically just if you take a number, you try to find out what other number exists such that when you multiply it by the first one you started with, you get the number 1. Okay? That's really all a multiplicative inverse is. And you'll see this is going to be directly extended to matrices here in a second. So some more examples. The multiplicative inverse of the number 3 is 1/3 because when you multiply these things together, you get 1. Okay? So this number here is called the inverse of the number 3, the multiplicative inverse of the number 3. Another example, just to deal with numbers because I like dealing with numbers, multiplicative inverse of the number 2. Okay, what number can you multiply by -2 to give you a positive 1? Well, you have to multiply by -1/2. Right? Negative times negative gives you positive, and so you'll get a 1. So this number is the inverse. So far so good. So far so good. I've tried to hopefully break down that barrier. The inverse concept is really not hard. It's just you take a number, and in this case we'll actually be taking a matrix here in just a second. We're going to try to find another matrix such that when you multiply them together, you're not really going to get the number 1, but you'll see it's going to look very similar. You're going to get something with a bunch of 1s in it, okay? And that's what it is. But that is called the multiplicative inverse. Okay, so let's go ahead and talk about matrix inverses, okay? So here's the definition, and we'll get to some problems. The inverse, okay, that's a definition, so I'm going to underline it, of a matrix, okay, is defined as follows, okay? And you must have, for a square matrix, okay, we'll talk about that a little bit more. But when you take the inverse of a matrix, it has to be a square matrix. And for a square matrix, I'm going to go ahead and put in parentheses n by n. That just means n rows and n columns, same number. So you have a square matrix, okay? Then basically what you have is a matrix. We're going to represent it by the letter A. I'm not going to draw the entire matrix out on the board, but you could just say that this letter represents an actual matrix that you would draw here. Matrix A multiplied by the inverse of matrix A. This -1 is not an exponent like you think about in algebra. Okay, it's not raised to the -1 power. This is a notation that just means this is an inverse matrix of the one you found here. It's the same letter, and so this is an inverse of this one. I haven't even taught you how to calculate that inverse. We're going to do that in a second. But for the inverse of a matrix is defined that you take a matrix, you multiply by its inverse, and you get what's called an identity matrix. You call that I. The sub n is just because it's an n by n matrix. Okay. Now, here's a bunch of gibberish on the board. What does it really mean? Okay, so here, I sub n is very simple. You remember back before we were talking about the multiplicative inverse. Take a number, multiply by its inverse, you get a number 1. Take a number, multiply by its inverse, you get a 1. Take a number, multiply by its inverse, you get a 1. Well, here, we take a matrix, multiply it by the inverse matrix. We're not going to get a number 1. We're going to get another matrix. Okay, we already talked about that. So what would this identity matrix look like? Well, if it's 2 by 2, it's going to look like this. Okay, for 2 by 2. Okay, 2 rows and 2 columns. The inverse matrix can look, the identity matrix can look like this. You'll see a pattern here for 3 by 3. That's an inverse matrix. The inverse matrix can look like this: 1, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1. 4 by 4. Okay, you see what's going on here. Instead of saying a number times its inverse is the number 1, you say a matrix times its inverse is a special matrix with 1s along the diagonal. That's all you say. And depending on how large the matrix is, if you're dealing with a 2 by 2 matrix to begin with, its inverse is going to be a 2 by 2 matrix, and when you multiply them together, you're going to get an identity matrix that's 2 by 2 with 1s along the diagonal. If the original matrix you start with is 3 by 3, you calculate the inverse, it's going to be a 3 by 3 matrix. You multiply these and you're going to get an identity matrix that has 1s along the diagonal, and it's 3 by 3. Same thing, 4 by 4 matrix, you're going to find a 4 by 4 inverse. You do the matrix multiplication, you're going to get an inverse that has 1s along the diagonal, 4 by 4. And you just scale it up from there. 10 by 10 matrix times a matrix inverse is going to give you a 10 by 10. You're going to get a 10 by 10 identity. That's why it's called an identity matrix. It's just a matrix basically with zeros everywhere except for 1s along the diagonal. That's why it's called identity. You can think of the number 1 being identity. That's actually another mathematical definition. Number 1 is an identity number because you take something, multiply it by 1, you get itself. So it's an identity. You get back what you started with when you multiply. Okay, you learned that a long time ago too. You just may not remember that. But this is called an identity matrix for similar reasons because it has 1s along the diagonal. So we have not told you how to calculate the inverse. I'm just simply telling you the properties of the inverse. That is why it's called an inverse. Just like the multiplicative inverse here, it's a matrix that you calculate that's very much related to the one you started with. It's very special so that when you multiply them, you'll get this very special matrix at the end. And why would you ever use this? Well, we'll talk about that in the follow-on sections. But this inverse matrix is very useful for solving systems of equations, and you'll see how to do that in a little bit later. A couple of additional things I want to write down here. I'm going to put little stars by them because they are kind of very important for you to remember. Okay? The inverse matrix is what I'm trying to say, is only defined, and I hinted to this before, for n by n square matrices. All this means is that I can only find inverses of matrices that are actually square. 3 rows, 3 columns. 4 rows, 4 columns. 5 rows, 5 columns. If you are given a matrix that had, 2 rows and 10 columns, it's impossible to calculate the inverse. You cannot do it, okay? And that's because you can't find a matrix like this that's going to give you an identity square matrix on the other end. So you're only have to worry about this inverse stuff for square matrices, okay? And the final thing is, not all square matrices have an inverse. Most of them do, but not all of them do. So as you start calculating them, and we'll see why in a minute, But as we start calculating them, you might find that the matrix actually doesn't have an inverse at all. And that just means that the matrix that you were given, it's impossible, again, to find an inverse, so that when you multiply them, you get this ones along the diagonal. And that kind of makes sense when you think about it. If you just randomly make up numbers in a matrix, you start putting all kinds of numbers everywhere, you would think that you could eventually hit upon one so that you could never find this appropriate inverse, so that when you multiply them, you get this very special matrix on the end. And that's all it's saying. So two things. Inverse is only applicable for square matrix. N by n just means same number of rows and columns. And not all square matrices have an inverse. Actually misspelled the word matrices here. Not all square matrices have an inverse, and we'll see why in a second. So let's go ahead and move on, and let me actually show you how to calculate the inverse, which isn't that terribly hard for 2 by 2 matrices. What you're going to find out, and we'll talk about it in a second, when you're dealing with a matrix that's a 2 by 2 square matrix, very, very simple to calculate the inverse. No problem. You could do it in a hand calculator, okay? When you get to doing the 3 by 3 matrix, it's very much understandable, but there's a lot of opportunity for errors. You'll see why. But it's very much something you can understand. When you get to 4 by 4 and 5 by 5 and 6 by 6, you need to start using a computer, because it just gets to be too complicated. Again, not possible to understand. It's just very tedious to do. So most of the time you'll be dealing with 2 by 2 and 3 by 3 matrices in your homework and in your test. Okay, so the first thing we're going to do is we're going to learn how to calculate the inverse. Okay, because we haven't talked about that. All we've talked about so far is how to actually use it and what the definition of it is, okay? So if you were given, and what I told you a minute ago is exactly true. We're going to start out with a 2 by 2 matrix, and we're going to move into the 3 by 3 matrix. 2 by 2 matrix is very understandable, very easy to calculate. It's not going to be that hard. If you were given a matrix that had numbers here, let's call them A, B, C, and D. These matrices are going to actually have numbers, but in order to give you the formula, I have to put little letters for everything so that I can show you what to do with them. So just say these are all numbers, A, B, C, and D. Okay? Then, in order to calculate the inverse is going to be A inverse. This is not an exponent. It's just telling you it's the inverse of the matrix. It's going to be 1 over A times D minus B times C. A times D minus B times C. Now, this is just a number. These are numbers, so you're going to have to multiply this by a matrix. Okay? The matrix is going to be D, A, negative C, negative B. Now let that sink in. Pause the video if you need to, just sort of let it sink in. What's happening here is, in order to calculate the inverse, all you do, you put negative signs in front of these two letters. You leave them in their same spot, but you put negatives. You take these and you flip them around. That's what this is. And that's a new matrix. You multiply that matrix by a number. This is a number. This bottom stuff is just going to evaluate to a number. A times D minus B times C. And that's going to be a number, and you multiply it just like we've learned how to multiply a number by a matrix, and that's going to be the matrix inverse. Okay? That's it. Now, does this make sense to you? Does this make logical sense that this is a matrix inverse? Of course not. Okay? It doesn't make sense to anybody just by looking at something and just to know that that's what it would be. Okay, so if you look at that and it doesn't quite make sense to you how it could be the matrix inverse, that's fine, that's normal, okay? I don't know intuitively why this is an inverse, but I do know that when you use it, it produces a matrix that satisfies what the inverse is supposed to do, which means you take that matrix, multiply it by the original one, you get the identity matrix at the end, and we're going to do some problems here in just a minute to show you that. So don't worry about it if this just doesn't make intuitive sense. Someone somewhere has proved this, mathematical proof, pages and pages of step after step showing that this produces the one and only matrix inverse, and it's our job to, at this point in our education, to use that and to move forward and not, I'm not saying don't question it, I'm just saying don't worry about it if this just doesn't make intuitive sense to you how this could produce an inverse. Okay? I'm not giving you that proof, I'm just telling you that's what it is. Okay? That's all I'm trying to really say here. Okay, so does it work? Okay, well let's go ahead and see if it works. Okay. Let's say the matrix that I'm given is actually going to be 2, 3, negative 1, 2. That's a matrix. And I'm asked, calculate this matrix inverse. Okay? So what I'm going to do is I'm going to calculate the matrix inverse exactly how I have it written down here. 1 over A times D. This times this. So it's going to be 2 times 2 minus B times C. actually what I need to do, 2 times 2 minus b times c, 3 times negative 1. Okay, that's the first part. So I'm going to multiply by this matrix, and what I'm going to have is, if you look at the formula here, the little equation for you here, D and A are actually flipped from our original matrix, okay? But since it's the same number, it really doesn't much matter, so I'm going to put 2 here, and I'm going to put 2 down here, and then these two numbers here are negated. That's what that negative B and negative C is. You just put a negative sign there. So you have negative 3, and negative times this is just going to give you a positive 1. So you have a positive 1 down here. So we followed our little formula. 1 over A times D minus B times C, that's down here, okay, times the matrix with D and A flipped and with these two things negated. That's what we've done. Now let's go ahead and finish calculating that and see what we have. So that would mean that the matrix inverse is going to equal 1 over 2 times 2 is 4. 3 times negative 1 is negative 3, but I have a negative out here, so it's going to be plus 3. So 4 plus 3, and then on the inside, it's the same old thing. I've got 2, negative 3, 1, and 2. Okay? Let's go ahead and continue on a little bit more. Inverse is going to equal, this is going to be 1 over 7 times 2, negative 3, 1, 2. Now, what do you do when you have a number outside multiplied by a matrix? Our very first section of this class, or one of the first sections of this class, talked about that. All you do is you take the outside, since it's not a matrix, it's just a number out here, you multiply it by every term on the inside. Okay? So it's going to look a little messy, and by the way, frequently you're going to end up with fractions doing this almost all the time because you have a giant fraction out here. So you're going to have to kind of get used to dealing with the fractions. Okay? So you have a fraction, but you know it's really not that bad because we're just going to carry that fraction through. So 1/7 times 2 is 2/7. 1/7 times negative 3 is negative 3/7. 1/7 times 1 is 1/7. 1/7 times 2 is 2/7. All right, so that's it. We have 2/7, negative 3/7, 1/7, and 2/7, and that is actually called the matrix inverse. So on your test, if that's what you were asked to find, what's the inverse of matrix A, you would calculate it exactly like this, and you would circle your answer. Now, do we know that this is right? How do we have any clue that this is actually correct? Well, we can obviously check it. That's the nice thing about matrix inverses. You can always check it because what you're trying to find out by checking it is the matrix A times its inverse equal to, I'm going to put a question mark because you're checking it, the identity matrix. Okay, is it equal to the identity matrix? So let's go ahead, and the identity matrix has ones along the diagonal. Let's check that out. The original matrix A was 2, 3, negative 1, and 2. That was the original matrix, and we're going to multiply that by the inverse. You have to do it in the proper order. Remember matrix multiplication, you can't just flip the matrices and get the same answer, so you have to write them down like this. The inverse is 2/7, negative 3/7, down here 1/7, and over here 2/7. That's my second matrix, and you might have to brush up your skills on how to actually do the matrix multiplication, but remember you go over and down, over and down, over and down. So working on the first row, over and down, you have 2 times 2/7, okay? And in order to kind of not clutter the board too much, we're just going to go ahead and do this multiplication. 2 times 2/7 is going to give me 4/7, okay? Plus 3 times 1/7 is going to give me 3/7. Make sure you understand this. I'm going over and down. This times this plus this times this. 2 times 2/7 is 4/7 plus 3 times 1/7 is 3/7. That's the first number. Now let's move over and do it for this column over here. Over and down. 2 times negative 3/7 is going to give me negative 6/7 plus 3 times 2/7 is going to give me, 3 times 2 is positive 6/7. Okay, like that. So again, over and down. This times this gives me this, plus this times this gives me this. Okay, now I'm done. I can't go anymore because I've run out of columns. Now move to the next row. Over and down. Negative 1 times 2/7 is negative 2/7 plus 2 times 1/7 is 2/7. Okay, over and down. This times this gives me this. this times this gives me this, over and down. Now, let's go to the next column, over and down. Negative 1 times negative 3/7 is positive 3/7. Okay, plus 2 times 2/7 is going to give me 4/7. Okay, so again, this times this gives me this, this times this gives me this, over and down. Okay, now let's go ahead and continue on and see if we can make any sense out of it. So let's go ahead and continue right here. Let's go ahead and do the addition. We have a common denominator here. So you have 4 plus 3 is going to give me, on the top, 7/7, but 7/7 is just 1. This is going to give me a 0. Down here, negative 2 plus 2 is 0, so 0/7, so you're going to have 0. And over here, 3 plus 4 gives me 7/7, because I already have a common denominator. 7/7 is 1. So look what I have here. I have an identity matrix. That means 1's along the diagonal. It's 2 by 2, just like the original matrix I have was 2 by 2. And that's it. So it checks out. Yes, this is the matrix inverse. So really all you're doing is you're looking at your matrix and you're applying literally this little relation here. You label A, B, C, and D. You 1 over this stuff times this matrix defined like this, and you just do a little simplification, distribute it in, and this is the matrix inverse. This is how you check it. You multiply it by the original matrix. You should get this identity. Now you will have to deal with fractions doing this almost every single time. Because of this out here, you're almost always going to have fractions in here, so you have to be really good at keeping track of common denominators and thinking about your fractions and doing that. One more thing I want to tell you is, if you were given a matrix and you tried to do this stuff out in front here, all this stuff out in front, what would happen if you were to get a 0 out here? If you did AD minus BC and you actually calculated 0, well then you would have 1 over 0 out here, which is undefined or infinity. So what you would find is you really couldn't calculate an inverse matrix. And that's why in the beginning I told you not all matrices, not all square matrices have an inverse. This is how you would know that, okay? If you try to calculate it and you start getting garbage here where it's 1 over 0 trying to give you some kind of infinity or undefined or something, you're not going to have an inverse for that matrix. You're not going to be able to calculate it, and that's what that means, okay? Okay, so what if you have a matrix, just to get a little more practice, that looked like this. 3, negative 1, negative 4, and 2. Okay? And you were going to try to calculate the inverse matrix. Well, you would go 1 over AD minus BC. So A times D is 3 times 2 minus B times C, which is negative 1 times negative 4. Okay? So I kept all my signs explicit, so I didn't screw any signs up. Minus B times C, and you're going to multiply that by a matrix. You flip these two things around, D and A, so I'm going to have 2 and I'm going to have 3, and you just put negative signs in front of these two here. So this is going to be a 1 and a 4. So 2, 1, 4, 3, and you're going to have that on the bottom. So let's go ahead and continue simplifying this. So what you're going to have here is 1 over 6. Negative 1 times negative 4 is positive 4, so you're going to have minus 4. And you're going to have 2, 1, 4, 3, just like we talked about, like this, okay? Continue simplifying. 1 over 6 minus 4 is 2, so 1/2, times the matrix 2, 1, 4, 3. And again, to find the inverse, you're going to need to distribute this in, or to kind of multiply by every element. So the inverse matrix is going to actually equal 1/2 times 2 is 1, 1/2 times 1, 1/2, 1/2 times 4 is 2, 1/2 times 3 is 3/2. Because you're taking this and you're multiplying by the 3, 3 times the numerator is going to give you this, denominator is going to be the same, like that. So 1, 1/2, 2, and 3/2. That is the inverse matrix, and that's what you would circle on your test. And if you wanted to check it, which we're going to do here right now, then you would check to make sure that the original matrix you had times the inverse you got was equal to an identity matrix, which is just ones along the diagonal. That's it. So let's do that. Okay, so the question is A times its inverse equal, with a question mark, to the identity matrix? Okay, the original matrix was 3, negative 1, negative 4, and 2. Okay, multiplied by its inverse. okay, is going to equal 1 and 1/2 and 2 and 3/2. Again, you have some fractions to deal with, so you just have to be a little bit careful, but it's okay. We're going to do everything one little step at a time. So we're going to go and do this matrix multiplication. We're going to go over and down, over and down, over and down, just like we always do. So let's start. Over and down. 3 times 1 gives me 3, plus -1 times 2 gives me -2. Over and down. This times this plus this times this. Okay, go to the next column. This one times this one. Over and down. 3 times 1/2 is 3/2 plus this times this, which is going to give me -3/2. Okay, over and down. Moving along to the next row, over and down. -4 times 1 is going to give me -4, over and down. 2 times 2 is going to give me the 4. This times this gives me that, and this times this gives me that. Okay, let's move on to the next one. Over and down. -4 times 1/2 is -4/2. We'll do the simplification later. -4/2. Over and down. And over here, you're going to have 2 times the 3/2 here, which is going to give you 6/2. Okay, which is going to give you 6/2. Okay, so now that we have that done, let's go ahead and finish our math in here and just see if this actually equals an identity matrix. So let's go ahead and move up over here and just finish this up, okay? So what we have here, 3 minus 2 does indeed give us 1. 3/2 minus 3/2 does really give us 0. This really does give us 0. Now let's check this out. What this is going to be down here, 4 divided by 2, as you know, is 2, so it's -2. 6 divided by 2 is actually 3, so you're going to add these together, and this is going to actually be a +1, so you're going to have a 1 here. So yes, it does actually give you an identity matrix. So it's the same thing as before. You start with your 2 by 2, plug it into here, you're going to get some stuff on the outside, you're going to get a matrix, you simplify this, multiply this into everything, that is your inverse. To check it, take the original matrix times this one, and it should, through all of the math, give you an identity matrix. If it doesn't give you this identity matrix back, then you've calculated the inverse wrong. It's just the only way it can work out. That's the definition of what the inverse is. So we've done 2 by 2 matrices. We've talked about what a inverse is, and we've learned how to calculate it for a 2 by 2 matrix. It turns out when you get beyond the 2 by 2, it's much more difficult to calculate. Not impossible, just much more difficult, okay? So what we're going to do is we're going to go and look at a 3 by 3 example and kind of give you a flavor for how to do that. And certainly when you get past 3 by 3s and going into 4 by 4s and 5 by 5s, it's going to be extremely tedious. The more elements of the matrix you have, the much more steps you're really going to need to do. And when you get into 4 and 5 by 5 matrices, you really need to use a computer for that. It's just going to be too many little steps to keep track of. But let's go ahead and tackle a 3 by 3 matrix and show you how to do that one. Okay, now for a 3 by 3 matrix, finding the inverse is a little more complicated, but it's doable. It's just more complicated. So step 1, okay, you write it as an augmented matrix. What does that mean? I give you the matrix A. I want you to write it down like this. I'm going to change colors to make it clear for you. You put your matrix A in there just like I gave you, find the inverse of, and then you put little dotted lines, and then you put an inverse next to it. I'm sorry, you put the identity matrix next to it. This is the equivalent matrix with ones along the diagonal. So literally you're going to have the matrix you have, and you're going to have the identity with ones along diagonal on the other side of the dotted line. And you'll see why in a second. Okay, step 2. Okay, you do row operations, okay, until you get the following thing, and I'm going to change colors. You do row operations like I've taught you how to do until you actually end up with an identity over here and some other matrix over here. In other words, what you do is systematically, step by step, you'll take several steps to do this, you change the left-hand side into an identity with ones along the diagonal. just like we were doing before with the Gauss-Jordan elimination. You get the lower zeros, ones along the diagonal, and then you go and tackle the upper zeros. And as you're doing that, you're applying the same row operations to the right-hand side. So as you change the left-hand side into an identity matrix, you're actually transforming the right-hand side, which started off as an identity matrix, you're changing that to something else. That something else is the inverse, okay? So this would then be declared to be is the inverse of the matrix A. That's basically what you want to do. So you're going to start off with the matrix A, and you're going to start off with an identity matrix over here. You're going to do row operations until the left-hand side becomes a true pure diagonal ones with zeros above and zeros below. And then once you do that, the right-hand side is going to be your inverse. Okay, that's how you do a 3x3 matrix. So let's go ahead and tackle that now. Okay, so the question is, here's the problem on your test. And it says, here's a matrix, find the inverse. 2, 2, -1, 0, 3, -1, -1, -2, 1. Okay? And that is the matrix, and you're asked to find the inverse. So the very first thing you do, let me switch colors, is you just literally rewrite this thing again. Actually, you know what? Let me just save a little bit of board space here. This is your problem. Your first step on your test is going to be to write that down, put a dotted line here, and then write an identity matrix here. 0, 0, 0, 1, 0, 0, 0, 1. This is a 3x3 identity because you had a 3x3 to begin with. Okay? So this is what you were given. You write this down, literally. And what we're going to do is we're going to change the left-hand side to look like this. We're going to change it into an identity matrix, and then once we do that, the right-hand side is going to be transformed into something different. That's going to be our inverse. Okay? So let's do that. Let's do that. Okay? The very first thing we want to do, okay, very first thing we want to do, if you just look at what's going on here, you have 2, 2, -1, and you have some other stuff here. The very first thing you want to do is go ahead and try to make this a 1, because you want ones along the diagonal. You want to put a 1 here, zeros down here, 1 here, and so on. So the very first thing is just to try to do that. The easiest way to do that is just to divide this row, this entire row, by 1/2. So for the next step, it's just going to be 1/2 times row 1. That's what you're going to do, and that's going to change that into a 1. That's the very first step. Okay? Now, this is already a 0. That's very nice, but you surely would like this to be a 0 down here because you want to try to work on this guy first. Got a 1 up here. We figured out how to do that. This is already a 0. We want to change this guy to a 0. So the easiest way to do that is to take this row, multiply by 1/2. That's going to give me a positive 1 here. Adding it to this is going to give me a 0. So what you say is 1/2 times row 1 plus row 3. Okay, middle row we're not going to change because we already have a 0 here, and we're just going to leave that alone for right now. Okay, so 1/2 of row 1, 1/2 of 2 is 1, 1/2 of 2 is 1, 1/2 of -1 is -1/2. Go ahead and keep your augmented little line here. You got to apply this to everything. So 1/2 of 1 is 1/2, 1/2 of 0 is 0, 1/2 of 0 is 0. Okay. Middle line stays the same. 0, 3, -1, 0, 1, 0. Stays the same. Third row, we want to actually do this. 1/2 of this plus this. So 1/2 of 2 is going to give me 1 plus the third row. Gives me that. Going to this, 1/2 of this gives me 1 plus this. Gives me the -2. 1/2 of this is -1/2 plus the 1 down here. Okay, and over here, 1/2 of 0, I'm sorry, 1/2 of 1 gives me 1/2 plus 0, right there, okay. Here, 1/2 of 0 is 0, plus 0 just gives me 0. Here, 1/2 of 0 is 0, plus 1 just gives me 1, okay. So that's really all I have there. Now let me go ahead and just finish the math here, and then we'll figure out what our next step in the game plan is. So we have 1, 1. -1/2 augmented with 1/2, 0, 0. Okay, next line, 0, 3, -1, 0, 1, 0. Next line, 0, this gives me -1. This, 1/2 plus, -1/2 plus 1, you should think about that for a second. That gives you positive 1/2. Okay, And then over here, 1/2 plus 0 is 1/2, and you have 0, 1. So let me double check myself here. 1, 1, negative 1/2. 1/2 across there. Got that. Everything looks to be correct, okay? So we've made some progress. We have a 1 here, we have zeros down here. We're systematically changing this into an identity matrix, and you see how this one's changing as well. When we're finally done over here, this is going to be our inverse, okay? So the very next thing that I think I want to do when you think about it is I want to go ahead and put a 1 here, so I'm going to divide this guy by 1/3. That's going to put a 1 here. So let me go ahead and just kind of write down that's what we're doing. So here, we're going to say 1/3 times row 2. That's going to give me a 1 here. What can we do in the third row? What can we do in the third row? We want to make this guy a 0, okay? And the easiest way to do that is to take and multiply this by 1/3, which is going to give us 1, and add it to this, which is going to give us a 0. So we want to take, for this guy, we want to take 1/3 times row 2 plus row 3. And that's all in an effort to make this 0. 1/3 times this gives us 1, plus that gives us 0. We're not touching the first row because he's already looking pretty good so far. So 1, 1, negative 1/2, augmented. Over here you got 1/2. I'm going to try to keep my stuff lined up a little bit better. 1, you have negative 1/2, 1/2, 0, and 0. And for the second row, we're just going to multiply by 1/3. 0 here. This times a third gives us 1. This times a third gives us negative 1/3. This times a third gives us 0. This times a third gives us 1/3. This times a third gives us 0. Okay? And then the bottom one, we're again trying to make this guy a 0. So we multiply by a third and we add. So multiplying this by a third is 0 plus 0 is going to give us a 0. This is going to give us 1/3. It's going to give us 1 minus 1. Because 1/3 times this gives us 1, plus this gives us our negative 1 down there. We're doing subtraction. 1/3 times this is negative 1/3 plus the 1/2. 1/2 being from down here. 1/3 times this is just going to be 0 plus 1/2. So you're just going to be left with 1/2 down here. 1/3 times this is going to be 1/3 plus the 0 from here, is just going to give you 1/3. 1/3 times this is going to give you a 0, plus this is going to give you a 1. So this is all going to really look like this. You're going to have 1, 1, negative 1/2, 1/2, 0, 0, 0, 1, negative 1/3, 0, 1/3, 0, and so on. Okay, so let's go ahead and finish our math. We have 1, 1, negative 1/2, augmented. On the right, we have 1/2, 0, 0. Over here, we have 0, 1, negative 1/3, 0, 1/3, 0. Over here, let's do our subtractions. 1 minus 1 is 0. This, you have to think about. Negative 1/3 plus 1/2. Negative 1/3 plus 1/2. And you really need to go off in the margin and figure that out to actually figure that out when you do your fractions. It's just going to be a little bit easier for you. So let's move over here real quick. What is 1/2 minus 1/3, which is exactly the same thing as negative 1/3 plus a half? You really need to find a common denominator, right? So the easiest way to do that is to find a common denominator of 6. So the way I'm going to transform this thing is I'm going to change it, and I'm going to say 1/2 times 3 over 3 minus 1/3 times 2 over 2. I can multiply either of these fractions by something over itself without changing, because this is just 1 and this is just 1. I'm doing it this way so I'll get 6 on the bottom. Okay? So what I'm going to have over here is I'm going to have 3/6 minus 2/6, which is 1/6. That is what the answer is. When you're dealing with fractions, you got to find your little common denominator, so go ahead and do that in the margin. Okay? So this, just for your reference, was just more of an aside. 1/6. That's what we have down here. 1/6. Okay? And then finally over here, you just have your 1/2, your 1/3, and your 1. Okay? So we have 1, 1, negative 1/2, 1/2, 0, 0. Looks like everything's looking pretty good. Okay, and you can see, actually, even me, I'm doing this myself, and I need to check my work after every step because it's very tedious. And you see it's not hard, it's just tedious. So we've made some progress. We've got 1, 1, we've got zeros down in here. Obviously, the next step is to try to make this guy a 1, and we can also do some other things there as well. So the next thing we want to go ahead and do Let's go ahead and move over here, draw our matrix over, and let's put a 1 down here. Okay? So what we're going to have, and since we've actually already kind of used our little fraction math, I'm going to erase it and get it out of our way, just so it's not in our way. Okay. So what we're going to have then, just to finish things up here, so we're going to have this matrix. Okay? And what we're going to do is on this third row down here, we want to make this into a 1. The easiest way to do this is to multiply by 6. 6 times row 3. That's going to make him a 1. Okay? Now, at the same time, we want to make this guy a 0, right? I think we want to make this guy 0. So what we can do there is multiply this row by -1 and then add it up there. So we can say for this one, negative row 2 plus row 1. Negative of the second row, adding it up here is going to give us a 0 up there. And then finally, this is the thing that's a little bit interesting to think about. If we want to make this a 0, we can certainly do that here. When you really think about it, if we take this fraction and we multiply by 2, 2 times a 6 is going to give us 2 6, which is also 1/3. So if we multiply by 2, we're going to get 1/3 plus the -1/3 is going to give us 0. So we want to multiply by 2 in the third row and add it up here. So this is 2 times row 3 plus row 2. Okay? 2 times row 3 plus row 2. Okay? So let's go ahead and do all of that. First thing we need to do is take the negative of the second row and add it up here. So negative of 0 is just going to give you 0, plus 1 is just going to give you a 1. Not going to really change anything. Negative of this, -1, plus that is just going to give you a -1 plus 1. That's what we're trying to accomplish. -1 of the -1/3 is going to give you positive 1/3. Okay, so you're going to get positive 1/3 minus the 1/2 up there. Okay. Down here, negative of 0, 0 plus that's just going to give you the plain old 1/2. Okay. Negative of this row is -1/3 plus a 0 is going to give you -1/3. And then negative of 0, 0 plus that, you're just going to have a big fat 0 there. Okay. Now in the second row, we want to multiply the third row times 2 and add it to the second row. We're doing this because we're trying to multiply this by 2, giving us positive 1/3. We add it to this, that's going to give us a 0. So let's do it. 2 times 0, 0 plus 0 is 0. So that really doesn't change. 2 times 0, 0 plus 1 is going to give us 1. That really doesn't change. 2 times 1 6 is 2 6, which is a third. A third over here. So what we're going to have is we're going to have 1/3 minus 1/3. Okay, that's what we're going to have for this. Here we're going to multiply this by 2. So it's going to be 2 times a half, which is 2 halves, which is 1. 1 plus 0 is going to give us 1. Here we're going to multiply by 2. 2 times a third is 2/3 plus 1/3. 2/3 plus 1/3. And here we're going to multiply this. 2 times 1 is 2 plus 0 is going to give us the 2. Okay? Now finally, the last row, we're just going to multiply by 6 because we want to get him into a 1. This is going to be multiplied by 6 is going to give us 0 and 0. 0, 0. 2 times a 6 is, 6 times a 6 is going to give us 1. So that's going to be 1. 6 times this is going to give us, I'm just going to write it as 6 halves to keep it straight. 6 times this is going to be 6/3 to keep it straight. And 6 times 1 is just going to be 6. Okay, so let's just go ahead and do our math and make sure we've done it right. 1, this is going to give us a 0. What is 1/3 minus 1/2? What is 1/3 minus 1/2? And I think if you do that in the margin, what you're going to find is 1/3 minus 1/2. We need to change the common denominator, so we're going to take the 1/3 multiplied by 2 over 2. We're going to take the 1/2 multiplied by 3 over 3. We haven't changed anything. We're just getting the common denominator of 6. So here we're going to have 2 6 right there. And here we're going to have 3 6. So the answer is going to be -1 6 because 2 minus 3 is -1 over the 6. So you actually get a -1 6 for this. So -1 6 augmented. Over here you have 1/2. You have -1/3, and you have 0. Second row, you have 0, 1. Third minus a third is 0. Okay, over here you have 1, 2/3 plus 1/3. You can see right there that's going to give you 3/3, which is going to give you 1. And then you're going to have the 2. And then over here you're going to have 0, 0, 1. 6 divided by 2 is going to give you 3. 6 divided by 3 is going to give you 2. 6 is just going to come along for the ride. So you see we've made a tremendous amount of progress in that last step, because now we have 1s along the diagonal, 0's down here, 0's here. The only thing remaining is the 1/6 up there. So really all we need to do is figure out a way to make that guy equal to 0, and then we're going to go about our merry way. The easiest way to do that is to take this row, multiply by 1/6, positive 1/6, and then we add it up here. That's going to give us a 0. So let's do that. Okay, what we're going to do, and since we're actually finished with our little margin math here, I'm going to erase it. And what we're going to do for this top row here is we're going to say row 1/6 times row 3 plus row 1. That's what we're going to do. Okay? And that's going to give us 0 up there. So that's what we're going to do. So let's go ahead and do that. 1/6 times 0 is 0, plus 1 is 1. 1/6 times 0 is 0, plus 0 is 0. 1/6 times this is 1/6. So I'm going to go ahead and keep it as 1/6 minus 1/6 because we're adding it up here. I don't want to do too many things at once and get myself confused. Over here, 1/6 times this is going to give you 3/6 plus 1/2 because it's plus this up here. Down here, you're going to have 1/6 times this is going to be 2/6 minus the third from up here because I'm adding it up there. And then you have 1/6 times this, 6 times a 6 is 1, plus the 0 is just going to give you the 1. Everything else in the matrix is actually unchanged. So you're just going to write it down just to carry your work through. You see why, you see why I say this is not hard, because it's easy to understand each step, but it's incredibly tedious to make sure that you do all this math correctly, this basic arithmetic. So 1, 0, 1/6 minus a 6 is 0, finally making some progress, augmented. Okay, what do you have here? 3/6, I think you can convince yourself, is exactly equal to 1/2, right? 3/6 is 1/2. 1/2 plus a half is 1. So I'm going to put a 1 there. Okay? In fact, let me just be explicit about it and say 3/6 is 1/2 plus 1/2, just to make it just totally clear. 2/6, if you reduce it, is going to be equal to 1/3 minus 1/3. Okay? This 1 comes along for the ride, and the rest of the matrix, I'm just going to write it down just to carry it. I could have done the math here, but I'd rather just kind of keep it clear so nobody can get lost. Okay, final step, I think, for this whole thing. You can see on the left-hand side, we finally have arrived at an identity matrix. On the right-hand side, on the top, 1/2 plus a half is 1. 1/3 minus 1/3 is 0. You have a 1 here, and then here you're going to have a 1, 1. Over here is a 2. Here you have 3, 2, and 2. Like that. Okay? Now let me just check my work. That's correct. Now this matrix right here, this is the inverse of A. That's the inverse matrix. And if you were to take the original matrix that we had and multiply it by this matrix, you would get an identity matrix. That's what's going on here. So let's recap from the top and just make sure we have it. You're given a matrix and you want to find the inverse. You put it in it with an augmented identity matrix on the right-hand side, and then from here on out, you start beating this into an identity matrix. Whatever happens to fall out on the right-hand side is what your inverse matrix is equal to. So we first started out by trying to make this a 0, and then this a 0. And we multiplied, and by adding rows, we were doing that. And then we made this a 0, and this a 1. Okay? We were getting down to something that kind of looked reasonable. Then we made this a 1 by multiplying by 6. And we did all that math here, and you see there's lots of fractions involved. We finally got to a point where we could do some additional math up here and make this a 0, and make this a 0. And then finally we were left with this being the only non-zero term. We just multiplied this by a 6 and added it to get that to be a 0. After that, we had the left-hand side in an identity matrix form. Once you're at that point, you're done. This is your identity matrix. I'm sorry, your inverse matrix, so that's it. So you can see how difficult it was just for a 3 by 3 matrix to calculate the inverse. There was a lot of steps there, and there's a lot of chance for errors. Any of these fractions that go wrong, or any of this addition that goes wrong, and the whole thing's wrong, and you'll look up here and everything else, and you'll have a hard time finding your problem. So what you need to do, check your work after every single step. Trust me, it'll save you time. If you wait till the end and get it wrong, you'll be chasing math errors 5 matrices ahead of where you are, and you'll be killing yourself, erasing your page and going forward. So you need to check your work after every step. So we've talked about the inverse of a 2 by 2 and a 3 by 3 matrix. When you get beyond that, there are ways to calculate them, but really computers are your friend at that point. That's what you would do in real life to calculate the inverse of a 6 by 6. You're not going to do it by hand, you're going to do it with a computer, just because of the arithmetic kills you. Don't forget the point of it. The inverse is defined to be the matrix, so when you multiply by the original matrix, you get the identity as a result. Now we're going to use the inverse matrices in the following sections in applications of solving systems of equations.